All right, let's jump right in. What if I told you there's a new AI architecture out there that might just break through one of the biggest roadblocks holding the entire field back? It's called Kimi Linear. And according to this new technical report, it's not just faster, it's fundamentally better. So let's dig in and see what makes this thing tick. We're asking AI to do some pretty wild things these days, like analyze a company's entire codebase, or read a whole library of books in seconds. But the bigger our requests get, the more we're hitting this wall. The whole process gets super slow, crazy expensive, and just plain inefficient. But what if there was a way to get it completely unstuck? Well, this report might just have the answer. Okay, so to really understand why this is such a huge deal, we first need to pop the hood and look at the core problem. The researchers call it the attention bottleneck, and it's pretty much the main reason everything's been slowing down. So what's actually happening here? Why is AI hitting a speed limit right when we need it to be flooring it? Well, the answer is all about how these models, how they think. The big issue is a core mechanism called attention. Now, the computational cost here doesn't just grow, it grows quadratically. Think of it like a traffic jam. If you double the number of cars on the road, the traffic jam doesn't just get twice as bad, it gets 4 times worse. In AI, this creates a massive memory problem called the KV cache. It's like the traffic is so bad, the cars literally start piling up on top of each other, and everything just grinds to a halt. But what if you could just redesign the whole system to avoid that traffic jam in the first place? Well, that's exactly what this new architecture promises to do. So let's meet Kimi Linear. Okay, the team behind this makes a really bold claim. They call it a drop-in replacement for full attention architectures with superior performance and efficiency. Now, that is a huge statement. They're not just saying it's a little faster, they're saying it's actually better, and you can just swap it right in. So how on earth did they pull that off? So what's the secret? What's the magic trick? Well, it all comes down to a core innovation they call Kimi Delta Attention, or KDA for short. And this right here, this is the secret sauce that makes the whole thing work. Think about it like this. Older AI methods are kind of like having a single white switch for a whole room. All the information gets blasted with the same amount of attention, whether it's important or not. KDM, on the other hand, is like having a dimmer switch for every single light bulb. The report calls it fine-grained channel-wise gating. It can dynamically adjust the importance of every little piece of information, so it only focuses its power where it's needed most, and that makes it way, way more efficient. But KDA doesn't work in a vacuum. The real genius here is how they've combined it with the old, powerful methods. This hybrid approach creates a kind of architectural superpower, giving Kimi Linear the best of both worlds. Kimi Linear uses this simple but brilliant 3-to-1 ratio, so it stacks 3 of those super fast, super efficient KDA layers for all the detailed work, and then every 4th layer, it slots in one traditional full attention layer. That one's job is to connect all the dots and see the big picture. It's this perfect blend of speed and comprehension that nobody else has really nailed down before. And the result of this clever hybrid approach, it's just staggering. It reduces that memory-hogging KV cache, that traffic jam we talked about, by up to 75%. That's not just a little improvement. That is a massive leap forward that changes the entire game. Okay, so the theory sounds incredible, right? But does it actually work in practice? Well, the research team put Kimi Linear head-to-head with the standard models, and yeah, the results are pretty clear. So first up, a test of basic language understanding and reasoning. And look at this. Kimi Linear doesn't just keep up with the old method, it actually surpasses it, scoring a 51.0 versus a 47.2. This proves it's not just more efficient, it's also more effective. And this is where Kimi Linear really starts to pull away. When it comes to processing huge amounts of information, its advantage just gets bigger. On the ruler benchmark, which is designed for these massive tasks, it pulls ahead again. This architecture is clearly built for the giant data sets of the future. So what does all this efficiency and performance mean for raw speed? This number says it all. When it's decoding 1 million tokens of text, Kimi Linear is up to 6.3 times faster than the standard model. That is a night and day difference for any real-world application. So when you combine the better performance, the massive efficiency gains, and that incredible speed, it's pretty obvious we're looking at more than just a slightly better model. This is a real glimpse into a fundamentally faster future for AI. So why is this so important? Well, a breakthrough like this could unlock the entire next generation of AI.
The report itself talks about enabling agentic intelligence, basically AIs that can perform complex multi-step tasks in the real world and analyze enormous data sets in real time. This could finally be the key to overcoming the scaling limitations that have been holding AI back.
Kimi Linear isn't just an improvement. It's a potential paradigm shift that smashes right through AI's biggest bottleneck. And it leaves us with one really exciting question. What are we going to build when AI can finally think at the speed of light?